Eli, I'm going to mute off and let you run the show.
Good.
All right. Hello, everyone. Welcome to Easy Computer Science Instruction with pitop at school or at home. My name is Nina Sclafani. I'm the Senior Event Coordinator for Tech. And we are just starting day 2 of our Tech Virtual Summit. We had a couple of really great sessions yesterday. You'll be able to view those as we upload them onto our YouTube page, so you don't have to miss anything that we've already covered. We're going to start in just 2 minutes, but I want to allow some time for people to start filtering in. If you're just joining us, welcome to Easy Computer Science Instruction with pitop at school or home. If you haven't registered for the rest of our sessions that we're hosting this week, we have 19 amazing sessions scheduled for over these 4 days. So the last day of the summit is Thursday. We have some upcoming stuff that you should really check out. Our next session is with Rube Goldberg, which I like to remind people, Rube Goldberg, my favorite use of it is the Pee Wee Herman breakfast machine. So if you want to know how you could make a contraption like that and bring that to your students even while you're doing distance learning, make sure to tune in at 12 o'clock today. But if you're just joining us now, you are in Easy Computer Science Instruction with pitop at school or home. Okay, and we are going to get started. Hi everyone, like I mentioned before, my name is Nina Sclafani. I am the Senior Event Coordinator for Tech. I'm going to be helping moderate today's session. If you are new to Zoom, scroll over your screen right now and look at the bottom. You'll see there's a Q&A box and a chat box. Use the chat box to let us know who you are, where you're from, and if there's anything that you think really stands out in the session that you'd like to comment about. And if you have a question for our instructors today, you can ask that in the Q&A box. We'll answer them as we can, but if there's a question that is better suited for Eli and Buzz to explain, we are saving 10 minutes at the end to address those questions as well. Let's get started. I'd like to introduce to you Eli Phillips. He's the Customer Success Manager for pitop, and Buzz Wood, Buzz, you just told me your title, Business Development Lead. So everyone, welcome these two fantastic people, and let's get started.
Thanks, Nina. I appreciate that. Hello, everyone. Thank you guys for being here. I'm going to go ahead and share my screen. Give me just a minute to make sure that this is going to work correctly.
And apologies, I did also want to mention Jake Alverson is also going to be in the chat box. He'll be able to help answer any of those questions as well. He is our product specialist for pitop here at Tech. And I like to think a pitop expert / genius.
Oh, Nina, you flatter me. Thank you.
Okay, can everyone see the presentation there?
Looks good.
Awesome. I'm going to go ahead and get started with that then. So as Nina said, my name is Eli, and as you can see here, we're going to be covering 5 ways that the pitop 4 and further make teaching STEM and computer science easier, both in the classroom and at home. To get started, what I want to do is tell you just a little bit about us as a company, and to also tell you a little bit about the products that we're going to be looking at. So let's start with who we are. So pitop is a creative learning company with the goal of inspiring a generation of makers. We think that the world needs more makers contributing great products and tools and ideas to our shared future. So to make that happen, we make tools and content to help students learn by doing. We use modular technology to create opportunities for learning by making. We want them to develop skills that they can apply in the real world, so we focus on skills-based learning. And that's why all of the projects on our website focus on real-world things. So what are the products? Well, the first one is the pitop 4. The pitop 4 is a modular computer. It's not quite a desktop, it's not quite a laptop or a tablet or anything else. It's the brains for all of those things and more. With the accessories that we're releasing later this year and into next year, it can become a lot of different things. All of the stuff that I mentioned, but also rovers and machines and other stuff that our users can imagine. So if all of that sounds like a lot, let's keep it simple and start by just thinking about it as a desktop. As a desktop, the pitop is really easy to use. You can connect it to a monitor using our display cable. You can add a keyboard and mouse. When you boot it up, it'll ask you to set up your Wi-Fi, or you can plug in an Ethernet cable, and after that, you're off to the races. Now, as you can see here, you can actually also connect it to your laptop and just use the keyboard, trackpad, and screen from that. I actually use it that way most of the time, but the two methods are basically identical. As a desktop, the pitop 4 has all the things you'd imagine. It's got a browser, an office suite, games, multimedia applications, tools for coding and programming, very standard stuff, but even as a desktop, the pitop 4 is unique. And that's because of the next product that I want to talk about, which comes with the pitop 4. It's actually in that metal box in the picture there, and you can see a part of it attached to the bottom of each of those pitop 4s in the slide. And that is our foundation kit. The foundation kit is a metal bento box full of components for creating all sorts of interesting things. First, it holds the foundation plate, and that's the accessory that snaps onto the bottom of the pitop 4. You connect it, and now you have access to additional ports beyond the standard USB, audio, and other stuff you'd get with a regular computer. So now it can do things that other computers can't do. With these ports, you can attach components from the foundation kit, things like buttons and buzzers, LEDs, knobs, and sensors. These can be programmed to do whatever you want. So we use them with projects available on our third product, which I've already mentioned, and that's Further. Further is our online learning portal. It's home to all kinds of projects that you can use with the pitop 4, as well as some lessons on 3D printing and some projects for our older products as well. So with the challenges on Further, users get access to step-by-step instructions for getting started with physical computing and coding. But the lessons go beyond just step-by-step instructions. They give you new tools and new information, and then they ask you to apply those things in different ways. They ask you to take what you've learned and what you've done and to change it and to make new things as well. And this actually leads into those 5 ways that the pitop 4 and Further can help teach computer science and STEM that I was wanting to talk about. The first one of the things that I want to talk about is actually what we're looking at right here, and that's our content. There are a lot of specific details about our content that are going to help make it easier to teach computer science and STEM, but the 3 main points that I want to focus on are the ease of use. Kids can basically be self-guided on Further. The fun, these projects are actually enjoyable to do, and the editability. If you like our challenges, but you wish they were just a little bit different, you don't have to reinvent the wheel and rewrite the challenge the way that you want it. You can just take what we have and edit it. Everything that we have on offer is editable, and you can create your own stuff too. Currently, there are 16 challenges for the pitop 4 available on Further, and these challenges are designed to make it simple and easy for users to get started with Python coding and physical computing. Every lesson is aligned to the CSTA standards level 2. Right now we have 50 hours of content, and we're developing even more. So let's talk about those 3 ways. First, I mentioned that the challenges were easy to use. What you see here is an example of one of the challenges that you'll find on Further. It has an explanation at the top explaining what the user is going to be doing, and then below that is sort of a grocery list of the parts that you'll need from the foundation kit and the pitop. And after that, it goes step by step through a sort of beginner level process. The challenges are really easy to get started with. I showed this to a group of like 3rd through 5th graders, and within 45 minutes, they were completing challenges on their own totally independently. I was basically just walking around the room answering like random questions that they had or congratulating them on cool things that they made as I double checked their work. These were advanced elementary school students, but if they can do it, then the majority of middle and high school kids will have absolutely no trouble being self-guided and doing these projects on their own as well. Next, I said that the projects were fun. The things that students can make and the things that can happen are cool. Even just coding a light to turn on, which sounds incredibly simple, is very satisfying to do. It's like popping bubble wrap. So when you hit run and the light blinks exactly like you told it to, that feels good. And then that makes you want to make more things happen. And that sort of engagement it's difficult to get without the hardware component. We spend so much time like with our screens that screens just don't have the same wow factor as making things happen in the real world. You know, if you're just using code, that's not the same as using code to build a physical thing. And that's why it's so important that the projects on Further are powered by the pitop 4 and the foundation kit. Each of the challenges is going to start out easy so the kids can have an easy time getting going, and then the difficulty is just going to increase, asking them to take the things that they've just done and learned and build on them. So in that way, they're going to progress naturally and they're going to learn more easily. If a student does need help, a teacher who has never done this stuff before doesn't need to be intimidated either, A, because it's all really clearly explained, and B, because we have these teacher's guides. We also have the ability for you to create a PDF of any of the content that your students are working on. So you can take that plus the teacher's guide and create like a highlighted cheat sheet Bible of all of the challenges if you wanted to. The goal is just to make it as easy and helpful and flexible for you as a teacher and for your students as possible. Lastly, I wanted to talk about the editability and the fact that you can change our challenges. So here I've taken some of the pre-made lessons and I'm going to be adding new content to it. And again, this goes back to the idea of using real world materials. I think it's great to have students build something with the pitop 4, run their code, and then upload content of their real world physical creation. So it's not just code. So I can ask my students to upload a photo of their finished project or to shoot a video of the electronics components in action to show what they're doing. I could ask them to post links or articles to the research that they've done when designing their project. Further lets you add all sorts of checkpoints. And I think this is really great for when classrooms go remote, because even if a student doesn't have access to a pitop for some portion of the lesson, the content on Further still allows for work to be done even when they're at home. They can do those other things. They can do design and construction and things that don't require it. They can do the research portion and post that on Further. Because of the editability, if you wanted to, you could take our lessons, which are pretty big, and you could break them down into smaller lessons and then fill them out with these extra tasks, these design things, these creative things, these other details for the students, whatever you wanted to add into it. The flexibility is a big thing here, and that actually brings me to the second point on our list, which is asynchronous learning. Whether you're in a classroom or you're doing remote, the ability for kids to learn at their own pace and on different schedules is really helpful. And it's likely going to become critical for us as we continue to figure out how to deal with school during the pandemic. And Further helps you do this with the ability to work on projects in phases, the ability to work on multiple projects at once, the ability to submit and resubmit your code. I talked to a teacher recently who works at a school where the students are going to be going into school every other week. They're going to have an A group and a B group. So one is in school while the other is at home, and then they swap. Further allows teachers to create online classrooms, just like what you would do in an LMS. So you can take a classroom, you can make a classroom for each group of kids that you have, either your first period or your second period, or more importantly, within each class, your A group and your B group. And then you can assign them portions of challenges or whole challenges or all of the challenges, all at once, whatever you need to do based on the structure that you're going to be doing. So you can see here that I've actually broken down one of our lessons into 3 different components. There's the physical computing with the pitop foundation kit, the assembly. There's the code portion there in the middle. And then on the bottom right, there's designing a robot in Tinkercad that could be built with cardboard and the pitop components. So each of these things can be done in this order, but you could also adjust the lesson plan and start with the design thinking or start with the prototyping or getting familiar with Python code. You can just rearrange the elements. And that means that you can do these things in a different order than what we have and make it fit whatever shape your classroom has to be in the moment. Every lesson has elements of physical computing hardware, coding and software, and then the creative design work that can be done with things like Legos or craft supplies or Tinkercad. So you could have some kids go into the classroom and do hands-on work with the pitop 4, while other kids are at home working remotely on the other elements and the other parts of the project. Those groups of students could even be working together, where one group is in school working with the pitop 4 and foundation kit, and the other group is at home working with design elements and figuring out the code stuff, and they're collaborating on those things online. But we'll talk about collaboration a little bit more later. Right now, let's actually talk about how you set up these classrooms so you can understand how easy it is to do all of this stuff. The third way that Further can help you teach computer science and STEM is just in how easy it is to set up and manage your classrooms, students, and assignments. You can easily import from your LMS. So currently we have access to Google Classroom and Clever with just a couple of clicks. You can build multiple classes very quickly. So you could organize your first period, second period, third period, or your A group, B group, C group, however you want to do it all at once, and work on this really quickly, which is nice if you have to adjust your learning model as you're going throughout the year, which, as we're learning, can happen. And finally, I counted, you can assign challenges to your students in 3 clicks. So you log on to Further, and in 3 clicks, they have an assignment ready. Again, this is all designed to just be super simple. So this animation is going to move pretty quickly when I start it, but what you're going to see here is me importing a classroom from Google Classrooms. Further allows us to import from both Google Classrooms and Clever, and we're looking at adding other LMS as we go in the future. If you're using a different one, or you haven't even started using an LMS yet, you can actually still build classes and add students in Further as well. You just do it manually. It's sort of like an LMS-like functionality built into it, but the processes all work really quickly. So to import a class, you literally just log in, click the import button, and then you're done. Now all of your students, my class has 1 student, all of them are inside of Further, and you can throw them into a classroom really quickly. You create that basically a 1-2 click process, and then you're done. So now you have a classroom populated with students, and when they log into Further, they'll be able to open your classroom and see what you've assigned to them. And here you can see I've done just that. I've created a classroom. It has 1 student in it, my best friend since high school, who was kind enough to volunteer to be my student in a test class. And you can see that I'm editing the name and the description of the class so that when my students log on, they'll know what my class is about. I can add images and other content later to sort of flesh this out even more. But this is just, the basics of setting up a class, getting started really quickly. If you want to add one of our challenges, if you want to give your kids an assignment, it's as easy as opening that challenge from our main page and then clicking the Assign to Class button in the top right. After that, you just choose which classroom you're going to add it to, assuming you have multiple classes, and you're done. So now you have a classroom group with students in it, and you've assigned projects to them all very easily in a few minutes. And as they do the projects, you'll be able to see every one of their submissions. Next, I want to talk about that collaboration thing that I referenced earlier. One of the things that we think is important when students are doing project-based learning and working hands-on is collaboration. We all have different skills, and we can learn a lot about other people, but also ourselves by working with other people. And Further makes it easy to collaborate on challenges that have been assigned to the students. And it does that by allowing group submission. So you have a class of 20 students, you can divide them into groups of 2 or 3 or 4 or whatever, and that group will all turn in one assignment together. So you don't have to remember who's in what group. You don't have to keep track of the assignments from different people that are all in a group together. They can just turn in one thing together and it'll have all of their names on it really easily. You also can collaborate with teachers. You can have shared classroom management. So I said that you'll be able to see your students' submissions. If you have a co-teacher, you can add them and they'll have access to all the same things that you do. So they'll be able to add students, see the student content, all of that, just like what you're able to do. So that's really nice as well. And finally, you can actually collaborate on creating content too. So if a group of teachers wants to get together and make a series of lessons as a team, they can do that. You can add other teachers to the projects that you are working on and building for your students, or the things that you're editing. So you can work together with other teachers really easily. So here you can see me using one of our student accounts to create a submission. So I selected the class that I'm working in, and I can see all of the challenges that have been assigned to me. So I'm going to choose one that I haven't submitted work to yet, and then I click on the Create Submission button. It's just going to ask me who I'm working with. So I can just pick anyone else who's in that class, or I can say that I'm working alone. And as soon as I do, it creates a submission automatically that my teacher is going to be able to see. So you can run the code to make sure that it works right. You can also give your students feedback. Maybe they did something mostly right, but maybe you want them to add more. You can just add comments to that. And then the student will be able to read those, modify their work, and resubmit it as well. And speaking of submission and grading and those types of things, that's the final way that Further and pitop make things easier. Students can submit their work really easily. Like I said, the second they jump into a class, they're going to see their assignments, they can hit Create Submission, and you're automatically going to have access to that submission. So they can then work on it until whatever you've set as the due date, and then you can take a look at it and assess it. Teachers can comment on student work. I mentioned this a little bit just a second ago, but while the students are working, every lesson basically has like a message board attached just to that student worksheet. where the student or group of students and the teacher can comment back and forth to each other. And this is really great if you're doing collaborative assignments. This is really great if you're doing remote work. It's very important for those things. And as I referenced, assignments can be submitted and resubmitted. So if you have a group of students working together, some are remote, some are in the classroom, people are working asynchronously, where one part of a project is being done now, another part is going to be done later. You know, because of the fact that those things are automatically saved and you automatically have access to them, students can do one portion of an assignment, you can see it, check on it, they can work on something else, then come back to this one and resubmit it. It's all about, you know, working with you, how you need to build your class in a given moment. We just want to have that flexibility so that you're able to do the things that you need to do in your classroom. So when students are doing projects in Further, they're writing code to make things happen. But how do you know if they did a good job? How do you know if they made the things happen? You get their code. So every challenge asks the students to write code, test it, and then submit it once they've done it. And then you're able to see it. So here we have a student who is having trouble with their code. It keeps giving them errors. And I tried to write this the way that a student would write it, where I'm not actually giving a whole lot of useful information to the teacher. I'm just saying that I need help. That was always my experience. So they can add their comments here, and then you'll get a notification and you're able to see the comment on that specific assignment. So you'll know exactly, you know, which one of the projects they're working on that they're having trouble with. And you'll be able to see what's wrong. And then at this point, you, the teacher, can log in and create a comment just like they did, where you can look at their code, you can run their code, test it, you know, you'll be able to see what they see. You'll be able to help them out, let them know what's going on. You'll have that teacher's guide, which is going to make that easier for you as well. And then they'll be able to see your comment. Also, if they're working in groups, you know, if one student has trouble, another student can see the comment, look at it, and help them just within that group. So if you've got 4 students working together, by the time you get there to answer the question, it might be that they've collaborated and solved it themselves. This is all really good for remote work. You know, being able to do this sort of stuff is I think it's really different. Part of the reason that I think people didn't do computer science teaching as much in the past spring is because they didn't know how. They didn't know how to make these sorts of connections happen. You know, if the student's staring at their screen and I'm across town, I can't see their screen. And we've kind of solved all of that. You can see the work that they're doing. Their peers that are working with them can see it. They're able to help each other. You're able to help them. It's just like a student's raising their hand and you're walking over and looking over their shoulder at what they're working on. So I really think that that's great. Finally, what you'll see here is one of my students, again, my best friend, has finished a submission and he's making a comment. You know, I'm telling him that he got all of the work right and he can move on to the next stuff. If he'd done something wrong, I could say, hey, go back and check this part of it. But basically, we're just able to have that full conversation that I'm talking about. And what I like about this is that if you have kids, you know, working on projects in pieces, like I said, they can do the first part of it. You can make a comment and be like, yep, this is good. Now go work on this other thing. Next week, we're going to come back and do the next part of this. So if you do have kids working asynchronously, if some kids are moving faster than others, you can say, do this part of it. They can say, I did that. Will you check it? You can pop in and check it. Again, it's super easy and super flexible for working the way that you need or want to work in a lesson. And I think that that is really important. So those are the 5 ways that I want to talk about. And we're going to do a bit of a recap of those in just a minute, but I wanted you to see some of it in action. So I'm going to attempt a demo right now. And the demo's going to be easy. It's just going to be switching my screen that I want to make sure I get right. So I'm going to exit out of that. Can everybody see further on my screen there?
Yep. Got
Perfect.
Yep, Eli, we can see it.
Okay, I'm also going to switch my camera so that you can see my pitop 4. So I've got my pitop 4 here in front of me, and I've got Further set up, and I'm actually going to start by going to one of our foundation tutorials. The foundation tutorials they're not like the lessons that we have where you're learning a lot of the principles and things. These are really just for getting familiar with how to do the projects. This is more teaching you how to use Further and the pitop than it is teaching you Python and physical computing. So I'm going to follow the instructions that it gives me, and it's telling me that I need to connect my foundation plate. I'm going to do that. The foundation plate just snaps onto the bottom, and then I'm able to go to the next step, and it's telling me to take one of my LEDs. I've got one of those right here, and one of my cables. I've got one of those right here, and I'm going to connect the cable to the LED, and then it's telling me to plug that into port D2. All of the ports are labeled down here, so I'm able to find the right one really easy. They're even color-coded. So now I've got that. Try and bend that wire so that my LED stays visible up here. There's a lot of these different, well, I'll have to hold it. there's a lot of these different component tutorials, and I chose this one just because the LED is going to be easiest to see, but now mine's rolling over. So I'm wirelessly connected from my Mac to my pitop. So I'm able to send the code that I've now got in front of me just by hitting the connect. I'm already connected, and then hitting run. So when I hit run, it's just going to run the first piece of Python code I've ever done as a student. So this is exciting. And all that's going to do is just run the LED. It says, let's see if the LED turns on. And then once the code runs successfully, it says, great, you did it. It turned on for 4 seconds. Can you make it turn on for 10 seconds? And it highlights the area. So now it's getting me comfortable with the idea of editing my first piece of Python code. So if you have a student who's never done any of this stuff, and it maybe seems intimidating looking at a wall of code like this, we're really sort of holding their hands in the beginning, which is great. So I hit run again, and it's going to send the code over, and it's going to stay on for 10 seconds. And then as soon as that's done, I've had my success. I have hooked up physical computing components. I'm working with electronics. I'm running and editing Python code by myself, so I can feel confident. And then I can go back and do more of those foundation challenges, those foundation tutorials, or I can move on to the sort of the larger challenges that we have. And I'm feeling good right now, so I'm gonna do that. I'm gonna pick the first challenge, the launch. This is a really good one to get started with. We're not gonna go through this whole challenge, but I just kind of want to show it to you. So like we said earlier, you can see it starts off with a description of what you're going to be doing, and then a list of the parts that you're going to need, and then an explanation of the first steps. Everything we do is going to be built into what we call assemble, tinker, play, and share mode. So assemble is basically everyone following the same instructions, and they should end up with the exact same results. So we're going to go through these assembly instructions. It's going to tell us how to set things up. On this one, we're just using the screen, so there's not a lot of hardware setup to do. And then it's going to give me sample code, just like what we did in that foundation tutorial, that I can run just to make sure that everything's working properly. And I get a cool animation of a rocket launch. This whole lesson is about simulating a rocket launch with the animation, with lights and a countdown, stuff like that. So now I've run my first piece of code. I could have done this without even doing one of the foundation tutorials. That was really easy. It gives me an explanation of what happened. And now it's going to ask me to go to the next step in the ATPS, which is tinker, where I take the code that they just gave me and I modify it. And I've actually already done this one, so I've already done the work they told me to do, but what they wanted me to do was to copy this line of text. This line is what made the animation happen. So they said, what happens if you duplicate that? So I've never done this before, but now I get to, I mean, I have, but the students never done this before, so now they get to experiment with modifying the code. So we're not asking them to write Python that they don't know what it means from the beginning. We're just saying, just tinker with it. And when I do that, of course, it's going to run the code twice. So we're going to see the animation the same as we did the first time, but now we're going to see it a second time. So this is showing them how easy it is to get started with this stuff. You don't have to be an expert in it to make things happen. And that's going to, once again, give them the confidence to move on. It's something cooler than just printing the words hello world. So that's also very exciting. They're going to want to keep moving with it. Here it says, you just made a loop, but there are other ways to do loops. Maybe you can learn the Python loop syntax from the W3 school, and then it even has a question. You know, what are the different ways that you can use to make a loop happen? So again, we learned something new in the assemble phase, and then we tinkered with it to really solidify that knowledge in our mind. And now we're going back into a new assemble phase. We're doing that loop again. It's going to have us use the buttons that are on either side of the screen on the pitop. It's going to explain how those work. It's going to give us some sample code. We're going to run that code, and what this one would do is it would make it so that that code runs the animation. And then afterward, it's going to ask us to tinker with it. It's going to ask us to make it so that the other buttons do something. Then we're going to add a countdown so that when we press the button, the screen says 5, 4, 3, 2, 1. So it's going to give us the sample code. And then again, we're going to tinker with it. And we'll go through that assemble and tinker loop over and over, adding new things, adding an LED, adding the countdown. And once we've done all of this, we've really learned a lot of stuff. And finally, it's going to stop doing that loop. And it's going to take us on to the next phase, which is the play phase. And it's just going to say, I'm not going to teach you anything new. You've learned a ton already. See if you can do more of this on your own now. You've made a cool thing. It's basically done at this point, but make it cooler. Can you add a buzzer? And it even gives us a hint. It says buzzers work exactly like the LEDs. And there's a buzzer tutorial, just a simple one that they can jump into if they're not confident to do this on their own. You know, it says, see if you can add a buzzer, see what you can make the buzzer do. How can you make more of a story about your rocket launch? What can you do to add to this and to tell more than just the launch taking off? You could add like a Star Wars style prologue of text that shows up on the screen before you get started. And at this point, it's just saying, we've slowly taken you out into the deep end. We haven't thrown you in, but now you're ready to kind of swim on your own and to do your own thing. And that's the goal of each one of these challenges. Each one of these projects is going to follow in that exact same way. And that's basically, you know, how it's going to work when you're in a classroom or at home using this product. So that's the demo. Now we've covered that plus the 5 ways that it makes these things easier. And again, those are fun projects that are you know, engaging, easy to learn, easy to customize, asynchronous learning that works in person and remotely, virtual classrooms that are quick to set up and simple to manage, effective collaboration for both students and teachers, clear and simple processes for submission, assessment, and review, and a bonus, 10 hours of web-based training with each school license. So any school that, you know, buys a set of PyTops and gets the license to use further, like I said, this stuff is pretty easy to get started with on your own, but we're going to give you 10 hours of web-based training as well to go along with that, just to make sure that you're comfortable with the product and you know how to use it. If you have any questions, you'll be able to, you know, ask those of us so that we're not just, again, throwing you out into the deep end on your own. So with all of that covered, if you do have any questions, I would love to answer those now.
Yep.
Like I said, those are gonna be, yeah.
We've got one from Gary asking about the industry uses GitHub and GitLab. Can PyTop integrate using those?
So that's a good question. The PyTop as a computer, it's really based on the Raspberry Pi, and it's a Linux-based computer. So it's already ready to go with things like GitHub. You can pull code down and you can run it inside of the Python IDE on the desktop, just like you would on any other computer. You could technically even copy code from GitHub into one of the coding windows on Further. So if I had GitHub open on my MacBook, I could copy that code into Further and then send it wirelessly to my PyTop as well without ever having to open an IDE. Yeah, that's a really good question. I've never thought about that.
Yeah. Well, one point to make after you've demoed this, Eli, would be that we've kind of pushed the envelope on making, because making, which has been around at least 5 or 6 years now and properly, has all been about assembly and putting things together. And I think with Further and with PyTop 4, we're seeing an evolution of making with meaning because you're actually doing something other than just assembling pieces and parts. You're actually controlling the code, playing with different variables, and it really, to say it, and Eli, you can expand on this, it's limitless what you can do with sensors and motors and all kinds of stuff, right? I mean, that are out there.
That's absolutely true, and that's a great point as well. You know, let's say you did find a project that someone else had done and it's up on GitHub. The PyTop 4, it's so funny, I just switched to my regular camera, but and now I'm regretting not being able to show you this. Hold on. The PyTop 4 has the GPIO pins. I don't know if you can see those or not, but it's got the GPIO pin access of a regular Raspberry Pi. So if you found a Raspberry Pi project that wasn't from us, you would still be able to do it. In fact, there is a company called Grove, and they make sensors that are compatible with our foundation plate. So those ports that are on the bottom there, I could buy other people's sensors, and actually I have. I bought like arcade style buttons, an EL wire, all kinds of things that I can plug into that. And then as long as you know how to do the code, you can actually control those from our kit as well. And it sort of becomes easier than using a regular Raspberry Pi for regular Raspberry Pi projects as well. But yeah, like you said, it's pretty limitless.
Lori's asking about the cost of the PyTop 4 and Foundation Kit combo.
I'm always bad at remembering the numbers. Buzz, you're our business guy.
Yeah, I would say that, Lori, it's $300 is about the average retail cost on that for educators. Comes complete with all the wires and accessories that you saw that are in the foundation kit that Eli showed earlier, plus of course the PyTop 4 itself. You know, as a complete kit, you get quite a bit of content and context to use. So that's what that is. Further sells as a software license outside of PyTop 4. And we can have you talk to the folks at Tech a little bit more about Further, because they're one of our best ever resellers in the education business. So they would know. Also, we got another question from Catherine. It says, hi, lots of schools are struggling with creating remote labs. Are you designing any challenges which meet physics learning outcomes, example and measure speed or acceleration, or any light/optic experiments, which is quite a bit of question there. So let's start with schools are struggling creating remote labs. We'll talk a little bit about what we're doing from a remote point of view, Eli. That would be good.
Yeah, so a lot of what you saw there in further about how we can do these things remotely, I think is really important. Some of our projects have even coding portions that don't necessarily require the pitop 4. So a lot of the code stuff can be done even if you don't. If you only had a classroom set of 10 of these, you would still be able to have a class of 20 students working because of the parts that could be done in different ways. That asynchronous thing of breaking it up that I was talking about. But also the foundation kit comes with an ultrasonic sensor for measuring distance. It comes with a light sensor. At the end of this year, we're going to be releasing another kit, a motion and motors kit, which is a lot more engineering focused, and it's going to have a camera and additional sensors as well. So there are going to be a lot of new projects coming out that are going to be actually much more physics based. A lot more math and physics and engineering is going to come out with the MMK, but this kit can do a lot of that stuff as well, just with things like the sensors that are in here as far as the light, sound, ultrasonic sensor, any of the inputs. So there is some of that that's happening. There's going to be even more of it by the end of the year.
Yeah, also worth mentioning is that we've got several schools around the country that are doing cyber security with pitop 4 and also hydroponics. So it's really also, I see here a mention of light and optics experiments. We've done those before with other applications. So I don't want to make it sound like it's sky's the limit, but it pretty much is. So it's a good one. What was the last thing that we wanted to touch on here? I think the other thing too is that we've had some schools that have thought about using the pitop 4 with the teacher, and then students would submit their coding that they're learning in further, and then the teacher would run it on her device or his device. So if there isn't enough, pitop 4s to go around, either in class or remotely, if it's a hybrid back and forth, that is one way we've heard teachers work around it.
Yeah.
That's a pretty good.
Actually, in regards to building out a lab while people are working remotely, obviously there are a lot of challenges with that. You either have kit parts that you're rotating out where, maybe 5 kids at a time get something and then it has to come back to the school and get disinfected and go back out, or it has to be a one-to-one where every student has a thing. And obviously that can be prohibitive for some schools. This is going to work in basically every one of those models. It's a really robust piece of hardware, so if you are passing them around, they're going to do pretty well in that. It's got the case that is in, it's got really good protection on it. It's our best hardware we've ever built. So passing it around between students is going to be fine. If you had a one-to-one, obviously that's ideal. But what you're talking about, you could absolutely run a class where none of the kids even have the pitop 4 in front of them. Obviously, it's going to be more engaging and it's going to be better the more hands-on stuff that they are able to do themselves. But if for some reason, maybe your school is going back in and everyone is going to be in school, and then suddenly something happens and now we're working from home, well, yeah, you can kind of make things work in those situations where, just like I had, a webcam pointed at my pitop 4 and you could see it here, you can do that in a classroom and the students can be the ones saying, all right, the instructions are telling us to plug this into this port, and the teacher's doing it with them. And the whole thing is working remotely like that. That actually is, a really easy solution in a time when you can't do this stuff otherwise. And the fact that you can do the whole lesson with the kit components that we have, it's all together in one thing. You've got the lessons online that everyone can use. It's built into the LMS. It's sort of an all-in-one out-of-the-box solution for doing that type of thing, I think, which is really great.
Yep. One point I want to reiterate that Eli covered and can't get missed is that certainly all of us, kids included, all do a lot of screen time, and that's okay. But I'll tell you, from a kinesthetic point of view, nothing beats getting your hands on this stuff and actually working with it from a physical computing point of view. So the 3 things that I think are real hallmarks of what we do is that we have this terrific platform with Further for projects projects and challenges. And then we have the coding component, of course. And then more importantly than anything is this physical computing, just the organics of doing that. It just can't be beaten. And it's, you talk about intrinsic motivation. Kids are just, you know, salivating for their turn to kind of get in there and start, you know, doing their Mr. Wizard thing where they're plugging stuff in. So, you know, I know Eli mentioned it earlier, and I wanted just to kind of bring that one to the forefront again about actually doing it. And that's, I think, the power of this, you know, tandem of Further and PyTop 4. Anything to add to that, Eli, at all?
Yeah, one of the schools that I'm talking with right now who have a PyTop 4, part of what they are doing is wanting to be even more sort of open and exploratory with it. They have a teacher who's like, the lessons are great, but I'm trying to get my kids into a much more open-ended, hands-on project-based learning thing than what schools are traditionally doing. And his kids are going to be basically using the component tutorials, just the basic instructions of how the foundation kit parts work. They're going to be using those and just exploring the parts. So the end goal is just figure out what these things do and then design thinking challenges. You know, how do you build something of your own with it? And that's what's really wonderful. We talked earlier about how the sky is kind of the limit. Once kids have gone through a couple of the challenges, or once they've gone through some of those component tutorials and they say, I know what this light is, I know how it hooks up, I know the code that runs it. Even if they can't write Python, the ability to just like copy and paste from the code samples that we have, you can cobble together your own thing really easily. I actually don't have a coding background at all, but most of what I've learned is just from using our projects. And yeah, you can take, you know, I don't know if everyone saw the picture there, but you can take these things and connect them to Lego blocks. And so now you've got this whole robust system where kids can kind of, very much in the same way as with Legos, you can build the things that we've told you to build, or sky's the limit, you can really explore. And that's the thing that I think is most powerful for kids, is that it's basically electronics version of Legos. You can just get the parts in a pile and start experimenting and building your own stuff with it. And that's what gets them really excited, is once they get through the lessons and they get that understanding and they're able to do that part of it, you know, where they're
For those who are listening, we have talked quite a bit about Python, but we also have Scratch included. So if you're doing, you know, object-oriented or object-based coding, then you know, you have that component as a stepping stone to Python. We've seen Python really take off because right now I think globally it's the #1 programming language. It's very strong in the CTE space and secondary education. So, you know, there is a scaffolding. If you said, well, I don't know if my kids are quite ready for Python, that's okay, because you can use Scratch to as a stepping stone. But, you know, as you saw Eli demonstrated, it really, we make it so approachable that, as Eli said, metaphorically, jumping in the deep end of the pool is not that scary, because we help you get to the edge, and, you know, and then people get confident and start playing with it and find out that those variables that seemed unapproachable are pretty easy to do. And that's, again, that's some of the beauty of the design of Further. So I just wanted to emphasize that there is some scalability, because we live pretty well in the middle school area on up into secondary, you know, 9 through 12. So that's kind of where we really hit that sweet spot.
Yeah, the 3rd through 5th grade class that I mentioned that I worked with, they started off, the very first thing we did is we spent about 10 to 15 minutes only with the device. I showed them very quickly a piece of code that I had written in Scratch that activated the lights, and then one that activated the lights using the button, and then one that activated the lights using the button, and it also had a buzzer. And I just gave them that sample piece of code. I didn't even really explain how it worked, but I showed them that on the screen, and they were able to start doing that stuff on their own in Scratch before we even got into Further and the Python coding. It was pretty immediate that they were able to start using Scratch with the PyTop 4. So within one class period, you can have kids prototyping and designing and creating their own things. They got out Legos, they got out cardboard, and they were building things, rudimentary things, you know, it's just buttons, lights, and buzzers. But they were able to do that within one class period and start designing and constructing their own stuff. And I said, cool, now we're going to take the training wheels off. Now you're going to use a real programming language. Nothing against Scratch, but we're going to use a programming language that can get you an engineering job. You know, we're not, I know that you're in 3rd grade, but we're going to do this now. And what you're going to see is it's almost no different than what you're doing already. And that gave them the confidence to do it. So yeah, that scaffolding that you're talking about is there. And I think that that's really easy and really wonderful. People get intimidated by this stuff because they see a wall of code, but they don't know what it means. but you don't have to start with that. Or if you do start with that, you can start with the version of it that we have that says, don't worry about writing that code. Don't worry about understanding what it means yet. Use it, and then start poking at it, and then start copying and pasting, and then start writing your own. You don't have to immediately know how to read and write all of it. And if you want to, dial back even further, yeah, start with scratch. Absolutely.
Nina, I think we're at our stop point, right?
I know. Unfortunately, we are getting to the hard stop. But if anyone has any additional questions, please don't hesitate to email us. You can email Jake Alverson at tech.com. He'll be able to help. And also, as I mentioned, we will be forwarding this information to all of you in an email within the next 24 hours. There's going to be a video of this presentation if you'd like to rewatch it, and the presentation slides. We'll also be announcing we have a raffle, I believe, right?
Yes, we do.
Yeah, so we will also announce the winner of the raffle through that as well.
A full pitop 4 and foundation kit combo. So somebody's going to get it, right? Cool.
Correct. All right. Well, thank you everyone so much for joining us. And thank you, Eli, and thank you, Buzz. This was absolutely wonderful. Everyone else, I hope you make it to the next session. We're starting at 12 o'clock with Rube Goldberg and Minecraft.
Thank you so much, everyone.
Bye.
Bye.